Hi everyone, good to see you again. Today I'm going to talk about the relation between different types of feeds and MMC and LMC. In this example, we have a pin with a diameter of 0.97 plus minus 0.1. We can calculate maximum material condition or maximum material exists on pin and least material exists on pin. 0.98 is MMC and 0.96 is LMC for the pin. If we are going to have a hole with the diameter of 1 plus minus 0.1, we can calculate LMC and MMC easily. Let's consider MMC condition for both of them. As we can see, the biggest diameter of the pin is smaller than the smallest diameter of the hole. There is a gap between these two. We can do assembly easily. Based on the gap between pin and hole, we are going to define different types of feeds. We have clearance feed, transition feed, interference feed. If the biggest diameter of the pin is smaller than the smallest diameter of the hole, it means we can do assembly easily. We are going to call it clearance feed. For transition, we can have clearance or we can have interference after assembly. For interference, the upper limit of the hole is always smaller than the lower limit of pin. It means we cannot do assembly easily. We need to use some tools and techniques. In order to implement these different types of feeds, we are going to use some standards. For example, here, ISO 286-2. Based on this standard, first we need to define zero line. In this example, the smallest diameter of the hole is constant, as I'm going to show you by mouse. It is constant. And uppercase letter is going to use for hole, and lowercase letter is going to use for pin. Let's talk, for example, for this D10 and H9. They are here in this table as it is defined in ISO 286-2. For this example, H9 and D10, based on the diameter of the hole or shaft, we are going to have different tolerance zone. For this standard, we are going to define international tolerance grade or IT grade, how we are going to fabricate these components. We are going to define what is grade for those components. We have talked about hole basis. Hole basis means the smallest diameter of the hole is constant. Uppercase letter H is going to use for that. And we have another scenario, we call it shaft basis. It means the maximum diameter of the shaft or pin is constant. We are going to have lowercase h here for that. And based on this combination, we are going to define clearance feed, transition feed, or interference feed. Another standard is ISO 2768. Based on this standard, we are going to have different classes with the name of fine, medium, coarse, and very coarse. And by considering the diameter of the hole or pin, we are going to define what is tolerance zone for that based on the class. Let's back to ISO 286-2. When uppercase letter H is related to the hole, it is hole basis. When we have hole basis H and A to H is going to represent this clearance fit. When we have, again here it is whole basis, uppercase H is here. When we are going to use J or JS, K, and M for pin, we are going to have transition fit. And for the rest, it means it is interference fit. Where we are going to use it, we are going to categorize which whole shaft combination is needed. By using these references, we are going to have several tables, and then based on the application, we can conclude which combination do we need. If it is for hub, for clutch, it is for gear, it is for coupling of gear, it is for flanges. We are going to use this combination of whole shaft tolerances. In this table, in the right-hand side, as we can see for interference fit, we may need to have some tools, the same as press or heavy drive fit. We need to use some techniques to do the assembly. For transition, maybe by pushing or maybe by force, it depends on the value as we are going to select for that application. Later on, I will talk in details regarding to standards, ISO 2768 and ISO 286-2. For now, just I would like to highlight the relation between different types of fits and LMC and MMC. I hope you enjoy it. Thank you for today. See you next time.